at a point. There are three conditions that must be true for a function to be continuous at a single location. Okay? So if I want to check for continuity at x equal to a, for example, you need to make sure you have all three checks. If one of the checks is not there, then the function is not continuous, okay, at x equal to a. So the first thing first, at x equal to a, the function needs to exist. That means there needs to be a point right there. Everybody okay with that? There have to be a point there. The next criteria is that the limit as x approach a from both sides of the function need to exist. That means the limit from the right and the limit from the left have to agree, and they have to come to a single y value. And last but not least, the y value of the limits have to be the same as the y value for the point. Once that happens, then the function is continuous at x equal to a. Okay? Imagine you have the removable discontinuity. If you have a point right there where that hole is being removed, then the function is continuous. But in this case, this is where the function fails, or the function is discontinuous when these condition fails. Okay? So if the first condition fail, that means the limit does exist. You can see the limit from the left and from the right does approach the same y value. But there is no point there. The point does not exist. So therefore, the function is not continuous at x equal to a. If the second condition fail, that means there is a point there. There is a point. The point is defined. But if you have a jump discontinuity, that means your limit does not exist, then the function is not continuous at x equal to a. If your condition 3 fails, that means if condition 1 and 2 are met, so the point exists. The point is right there. The limit exists. The limits from the left and from the right approach this y value. But you can see that the y value, which is your third condition, the y value of the point and the y value for your limit, they don't agree. You guys see that? So then based on that, your function still have a gap at that location. And because of that gap, the function is not continuous at x equal to a. Are we all right? Any questions on that? So this means all three conditions have to be met in order for the function to be continuous. When you do your work, in most cases, problem like this is a free response. So you got to make sure you show all three checks. Okay? We're going to go to an example so you can see how this is done. Given a function, and this is a piecewise function, x is not 3, the function is x squared minus 9 divided by x squared minus 3x. When x is 3, your function is the value k. So they're asking you, well, for what value of k is the function continuous at x equal to 3? So what you want to do is you want to assume that the function is continuous. And you want to use that assumption to find k. Okay? So we're going to write this. We're going to assume f is continuous at x equal to 3. Okay? And we're going to use that to find k. Now, if f is continuous at x equal to 3, that must mean that all three conditions are met. Are we good? So we're going to use that fact to find my k. Now, how do you find that? Well, the first thing is f of k have to exist. Now, at this point, I don't know what that is. Yeah? Well, actually, I do. My bad. No. I'm wrong. F at 3, that's 3. Y is k. There you go. You got to write that. So because x is 3. So I want to find the point at 3. So f of 3 is a number, and that number is k, since right now I don't know what k is. So that's the first check. The second check is I have to take a look at the limit. As x approach a, yeah, in this case, is 3 now. So we're going to change that to a 3. of the function f? Well, the function f, this is 3 from both sides. Well, that's represent both sides. Because when x is not 3, that means x can be 3, anything less than 3, which means on the left end. Anything more than 3, which means on the right end. So this represents left and right together. So we're going to have to find the limit for that one. There you go. Now to find that limit, I can factor, as you can see. Because if I were to plug in the 3 here, I would get indeterminate forms. So we have to factor it now. So that's what you always have to do. Plug in, substitute in your 3 for x, and then see if you have indeterminate. If you don't, then that means you can find your answer. If you do, you got to go back, factor it out. So I have x times x. 9 is going to be 3 and negative 3. So that when you multiply, you get negative 9. When you add, you make 0. That's why you don't have a sum. For x squared minus 3x, we can factor out an x. So we have x minus 3. So those are the factors. Once you have that, now you can cancel the x minus 3 right there. So once I have that, I can now plug in the 3. So 3 plus 3, that makes 6.
Miss, what about the x at the bottom?
Oh, right, you're right. Good catch. That means I have another 3, right? Good catch. Thank you. So now I don't have 6, I have 2. Good catch. Forgot the x there. Thank you. Good. So now this is what I know. I know that my limit as x approaches 3 is 2. Yes? So now my limit exists. The last condition says that, well, the y value of your point have to be the same as the y value of the limits. Do you guys see that? Well, you agree with me, the y value of the point is k. The y value of the limit is 2. So that means k have to be 2 in order for f of 3 to be equal to the limit as x approaches 3 of f of x. You guys see that? Now, when we write this, I don't have to write the expression because that's take too long. I only write that if I need to solve for it, to find the limit. You guys see that? Once I find it, I can just write the notation. So this is k, and the y value of the limit is 2. Therefore, k have to be 2. Questions on that? Yeah, I was wondering, like, wait, the answer is 6. Where's my 6? That's a good catch. Okay, can we move on? Yes? Okay. So go ahead and write it down, and then I'll move on. Go to the next page. Why don't you guys read the next page first, the next example? And let's see if you can do that one while we wait for everyone else. Okay. So here is example 2. All right. So again, it says, given f of x is a piecewise function, for what value of k is f continuous at x equal to 0? So again, we are going to assume f is continuous at x equal to 0. Okay? And then we're going to use that to find k. So remember, the 3 checks have to be there. Yes? I need you to do the first one. Okay, we're going to have to label it, I guess, so it's easier for us to do them, yeah? Go ahead and look at the first one. And if you don't know what the first one is, I'll put it right here for you so you can see. That's the point, yes? So this is f, your x is 0, so f of 0. What is it? And then the next one is your limits. Go ahead and do that. Hi, Em. Không có trong lớp này chữa là đúng rồi.
Okay.
Nicholas, Nick, there you go. Thank you, em. Alright, so this one is f of 0. Now f of 0, I can see that is a k. Yeah? So now I'm going to look at my limits. So this is the limit as x approaches 0. Now, if you look right here, hopefully by now you know that if x is not 0, that means that's considered the left of 0 and also the right of 0. Okay? So this expression represents both side limit. Is that good? Now, when do you have to find each one of them separately? When this is like x less than 0 and then you have another one x greater than 0. And that's when you got to know, okay, I have to take care of the left separately and the right separately. Okay? So I'm going to have to write this in. And hopefully by now you have an idea of what you should do next, right? You have an idea of what you should do next. If you take a look at 0, you agree with me that you have indeterminate form. Okay, so now you're going to have to rewrite this one. How should you rewrite this so that you can simplify? There you go. That's why you learn those first. So you're right. We have to multiply by the conjugate. And we're going to start right away so that we don't have to keep on rewriting this over and over again. Okay. The conjugate is the same value, the same term, but opposite signs for them. That way, when you distribute, yeah, the sum will cancel out. That's the idea. But I think we're going to have to write the limit, lim, x approach 0. We got to write small this time, yeah? So what I got on top is the square root of 7 minus 2x times the square root of 7 minus 2x is 7 minus 2x. A negative root 7 times a positive root 7 is a negative 7. Basically, it's the same terms, but get rid of the square root. Okay? And then on the bottom, we have a little bit more to take care of. You have x, and then times this entire conjugate right here. There you go. I'll zoom in so you can see, yeah? There. I'm going to have to erase this because I need more space than they provide. So here's the limit as x approaches 0. 7 minus 7 is a 0, so I have a negative 2x. So I have negative 2x divided by x times the square root of 7 minus 2x plus the square root of 7, like that. Okay? And hopefully you can see, hey, the x will cancel out because the x is the one that make my function indeterminate. Do you guys see that? So then we can cancel that out now. Since I have x divided by x, that's go away. And this, I can cancel it because this is multiplication. You can cancel that. Once that's done, I can now plug in the 0. So I'm going to start by just plugging in the 0. Once you plug in the 0, you don't have to write the lim anymore. Okay? This is 2 times 0. And then plus the square root of 7. Like that. That's going to be 0. So I have the square root of 7 plus the square root of 7. The square root of 7, add another square root of 7 is 2 the square root of 7. If you are not sure, remember this. Treat these like like terms, like x and x, kind of like that. So if you have x plus x, then you get 2x. But whenever you add, always add the coefficient in front of it. Okay? So 1 plus 1 makes 2. So that's 2 root 7. So what I'm going to get is negative 2 over 2 the square root of 7. Now hopefully you can see my 2 can cancel out as well. So what I have left is negative 1 over root 7. Please note, the square root of 7 is in the denominator. It needs to stay there. Even if you cancel everything on the numerator, if there's nothing there, make sure you put a 1. Is that good? Now that I find the limit, which took a little bit of time to find, I think you can see the answer already. You guys see that? But we're gonna write out so that you can see this in the notes, and hopefully it makes sense to you. The last step is that the y value of your point have to be equal to the y value of the limits. Well, the y value of your point is k. The y value of the limit is -1 over the square root of 7. So that's what your k is. So the answer is that one right there. It's A. The answer is A. Okay? Any questions on this one? Are we good? Okay. Go ahead and try 3. Go ahead and try 3. Go ahead and try number 3. I also print out a, this one you had it from pre-calc, right? You're gonna need this now for calculus as well. So if you don't have it, please grab one. This is the one I'm talking about right here. It will help you when you do trig using the unit circle. So that's why it's help. But on the back of it is now derivatives, which is something that you're gonna use, okay? So make sure you grab one for me. Go ahead and take a look at example 3, and let's get to work on that one. Okay. Now, a problem like these, if you were to be, if it's on a free response, you gotta show work like this, okay? However, if this is a multiple choice, then you don't have to show work like that. Multiple choice means once you get this answer, you gotta go find it in the multiple choice that you have. Do you guys see that? But when it doesn't give you a multiple choice, that's when you gotta know, okay, I need to show 1, 2, and 3. Okay? All right, go ahead. Let's get to work on this one. It says, for what value of k is g continuous at 2? So again, you are assuming g is continuous at x equal to 2. Okay? So now I'm going to start with my first assumption. That means g at 2 have to exist. Well, at 2 is k. All right, there's your k. Now we need to look at the limit as x approaches 2. Well, as x approaches 2, this means from both sides of 2. When x is not 2, that means x can be any number except 2. That means these are numbers on the left of 2 and number on the right of 2. So we can look at that expression for finding your limits as x approaches 2. There's really nothing for us to cancel. Hopefully you can see that, yeah? Right? So what we're going to do first is we're going to have to plug it in and see what we have. We will not have indeterminate, so we don't have to worry about that one. You guys see that? So this is just plugging it straight in. So I have, let's see, what do I have? I have 3 times 2, that's 0. And then, minus 6, that's a 0. Cotangent. You guys remember what cotangent is? Cotangent is cosine over sine. Yeah? So now that I have something like that, I need to check first though. Is my function, if I plug in a 2 here, would this denominator be undefined? You guys see that? Would this be undefined? Well, if I plug in a 2, what's sine of 0? What is sine of 0? What is it? It's 0. So we have a problem because what we have here is cosine of 0 is 1, but 1 divided by 0 is going to be undefined. Do you guys see that? So now that won't work for us. You guys see it? So I need to find a way to rewrite it so that I can not have that situation. Is that okay? So if you take a look at your identities. Let's see what you can do with that one. Is there something you can multiply to get rid of it? What else can you do? Go ahead and think about that first.